Welcome to all of you. Today we discuss on the guidelines of the use of the RNAM test code. Now the accuracy of the data is so important during the testing of the any implement. Now first point is selection of the test plot. The test plot should be rectangular with side length in a ratio of 2:1 as far as possible. If the field is irregular, then rectangular test plot should be marked for conducting the test, and the other portion of the field could be used for initial setting up and adjustment of the equipment. Now the next point is field operation pattern. The capacity and field efficiency of an implement are affected by the field operation pattern, which is closely related to the size and shape of the field. You can select any of this field pattern for field operation for the test plot. Now the speed of operation, two poles 20 meters apart are placed approximation in middle of the test run. On the opposite side also two poles are placed in a similar position and 20 meters apart, so that all four poles from corners of the rectangular. The speed will be calculated from the time required. For the machine distance to travel the distance of 20 meters between the assumed line connecting two poles on opposite sides AC and BD. You can see AC, these are the two opposite poles, and how much time is required to cover the 20-meter distance. We calculate as a speed. Now the wheel slip, the distance covered by the tractor in a given number of drive wheel revolution decrease with the wheel slip. The tractor or power tiller operated implement wheel slip will be affected the speed of the operation. And we calculate the numbers of revolution of the load or no load condition for mark test run. Now the draft measurement, it is again classified in two classes, that is manually operated, trail type, and tractor operated. Since the manually operated ready-made dynamometer for manually operated tools might not be available at present, but especially measuring apparatus must be devised and fabricated. Although the recording or indicating the type strain gauge meter can be utilized as a part of the apparatus, but it is expensive and too sensitive to field condition. And for trail type of implement, the draft required for pulling the implement can be measured inserting a spring or strain gauge type diameter between the hitch of the implement and power source. Therefore, D is equal to P cos theta, where the D is the draft in kgf, P is the pull measured by diameter is called as in kgf, and theta is the angle between the line of pull and horizontal. Now for mounted type, the implement draft can be measured by two tractors, and diameter implement is mounted on a tractor, and this tractor is stored by another tractor through the dynamometer measure the draft when the tractor is in neutral gear condition but implement operating condition, and again then implement is in lifted position. So you can see how to measure the power is equal to draft into operational speed by constant. This is the actually position how to measure the draft of mounted type of implement. Now the fuel consumption, again another factor. The tank is filled to full capacity before and after the test, and the amount of refilling after the test is consumption of the test. While filling up the tank carefully, attention should be paid to keep the tank horizontal and not to leave the empty space in the tank. The fuel consumption will give an idea of the energy requirement by the implement for the operation. Now next factor is the soundness of the construction. During the entire period of the testing, complete record of the defect and breakdown should be recorded and supported in the test report, and this should reflect to the great extent the soundness of the construction of the implement under the test. Now next is the field effective field capacity. Actual field capacity in terms of the area covered per hour is expressed as the effective field capacity, and this is denoted by the area covered in hectare. TP is the productive time and TN is the non-productive time. Now the field efficiency is the ratio of the field capacity of the theoretical field capacity, effective field capacity to theoretical field capacity. And you know the theoretical field capacity is calculated by the actual theoretical width and speed of the operation. And you know the field efficiency, not for the most of the tillage operation, field efficiency ranges between 75 to 90%. Now the soil moisture content on a dry wet basis is used for the soil for measurement of the soil moisture. Take a core sample of wet soil in at least 3 different locations of the test plot. Select randomly with the sample in a physical balance and record the weight of each wet soil sample. And place these samples in a hot air oven maintained at 105 degrees Celsius for at least 8 hours. At the end of the 8 hours, cool the sample in a desiccator and weigh them in a physical balance and calculate the soil moisture and using by the formulas. Now the next parameter is important as consider to the testing of the tillage implement like bulk density of the soil. It is calculated by the core cutter method. Now the bulk density is the mass per unit per bulk volume of the soil that has been dried to the constant weight at 105 degrees Celsius, and it is calculated by this formula. Now the cone index is an indication of the soil hardness and is expressed as a force per square centimeter required for a cone to penetrate into the soil. This portion is called the cone index, and cone index in the same soil varies with cone apex angle and area of the cone bottom. And apex angle and area of the diameter of the cone usually should be given in a report, but profile of the cone index to depth mean value of the working depth of the implement. Now the again another is the depth of cut, the vertical distance between the furrow sole and ground level as referred as the depth of cut, and their depth should be measured at minimum 10 places and it average taken. Now next important parameter is the soil inversion. The soil inversion is the process through which the furrow slice is inverted. Now as the soil inversion we consider as the number of weed present per unit area before the operation and number of weed present per unit area after the operation. Now next parameter again the soil pulverization is the process of breaking of soil into the small aggregate resulting from the action of tillage forces. The mean mass diameter aggregate it is considered so as a soil pulverization and can be determined by sieve analysis of the soil sample through set of standard test sieve. Sieving provides a simple means of measuring range of the clot size and relative amount of the soil in each size class. Now this is the procedure for to finding out the mean mass diameter. First collect the material from the area 150 by 150 millimeter and to depth of the operation of the implement. Second, weight of the material accurately and pass it through the set of sieve with aperture size given in this in millimeter. And then weight the material shifted through each sieve and material written on 11.2 millimeter sieve. Calculate the percentage of the mass of the material shifted through each sieve and that shifted and written on 11.2 millimeter sieve. The material passed through and written on 11.2 millimeter sieve should be taken as a percentage. Plot the curve with the sieve size and percentage of the mass material shifted through each sieve. Obtain the area of the shaded portion of the curve by planimeter. And obtain the mass mean diameter by multiplying the area of the shaded portion with MMD equivalent to 1 unit area in the graph. So this is the sieve analysis curve for the mean mass diameter. You can see plotted on x-axis sieve size in millimeter and on y-axis the accumulated frequency. Now the another method to pass the soil sample through set of sieve wedge the soil written on the largest aperture sieve and pass through each sieve and pass through the smallest aperture sieve. So you can calculate the mass mean diameter is equal to 1 upon W plus A plus 2.4 B plus 3.4 C plus 4.8 D plus 6.8 E plus X F, and you know the MMD is the mean mass diameter, W is equal to summation of A, B, C, D, E, F, and X is the mean measured diameter of the soil plot written on the largest aperture sieve. This is the table. You can see the mean mass diameter calculation method. First column is the size of aperture, second the diameter of the soil passing through the upper sieve and written on the next small aperture sieve. Third is the representative of the diameter of the soil, and fourth is the weight of the soil in kg. Use then adjustment and operation a complete record of previous forward is adjustment code the wide range of the operating condition, and ease of carrying out of the adjustment should be maintained during the apart from this, and the ease of the operation of the implement should be observed critically and reported. Now these are the references, and thank you.